Alright, so this is about density and pressure. You are required to define and use density. What did you say density is again?
Density is mass over volume.
Okay, density is mass per unit volume or mass over volume. It's simply mass over volume, mass per unit volume. Per unit volume, or simply mass over volume. So we use the symbol rho for density. Rho. So rho is equal to m for mass over v. Okay? We already know that. Alright. Now what's pressure? Yeah, what's pressure?
Pressure is density times.
What's the actual definition of pressure? What is pressure itself? The general definition of pressure?
Force per unit area.
Force per unit area. That's correct. Force per unit area. So pressure is force over area. Pressure is force per unit area. Alright, so that means pressure P will be equal to F over A, isn't it? So what should be the unit of SI unit of pressure or SI unit of density? If it is mass over volume, what should be the SI unit? SI unit should be what?
kg cm squared. Kg meter cube.
Kg meter cube, correct, both of you. Because mass is kg, volume is meter cube, that's per. So kg per meter cube, or kg meter raised to power minus 3, isn't it? So kg per meter cube, if you like. Because mass is kilogram, which is kg, volume is meter cube. So kg per meter cube or kg raised to power minus 3, if you apply your indices. So what should be the unit of pressure? What should be the SI unit of pressure?
Unit of pressure. That's the mass over area. That's kg cm squared. Or kg meter squared.
Pressure, I'm talking about pressure
Force
now.
over area.
Force over area. SI unit. I really don't need you to put it in base units. Just normal SI unit.
Kg.
No, just normal SI unit. Don't bother about base unit. I know you are now thinking like a big boy that you are. Try and respect your brother in the O levels.
Pascal.
So this is you can put it in Pascal or simply force. Force is Newton now, isn't it? Newton per meter squared. I know what you were trying to put it in base units. Okay, so SI unit is equal to Newton per meter squared or Pascal, isn't it? Newton for force per meter squared. And Newton per meter squared is also called Pascal, PA. So the SI unit of pressure is Newton per meter squared because force is Newton, area is meter squared. Newton per meter squared or Pascal. Of course, I know you can put it in base units. Alright. Now derive from the definition of pressure and density the equation of pressure, hydrostatic pressure. That's the one I want us to look at now. Okay, so let's look at it here. Are you ready for that? Look at this liquid in this container. Are you listening? This liquid in this container resting on this cross-sectional area A. On this cross-sectional area. The height of this liquid is h. Now, what is the volume of this liquid? The volume of this liquid. Assuming this liquid has it has a density rho. It has a density what? Okay, let me zoom this thing so that it will appear better. I can even squeeze all these things here. See the liquid? The blue coloring. It has a density rho. It's resting on this cross-sectional area A, and the height of the liquid is h. First of all, what's the volume of this liquid? Let's get that first of all. Volume of liquid. What's volume of liquid? How do you find volume? Well, we can use mass over density, which is correct. I can even write it down, mass over density, if you like. Then we eventually have to look for the mass. So you say volume of the liquid is mass over density because density is mass per unit volume. Okay, first of all, we know that. Let me start the way you want it. Density is mass over volume, isn't it?
Yes, sir.
So the volume of the liquid, which is V, are you ready? V is equal to what? Mass over density. Is that what you said? Okay, mass over density. But can we just find the volume of using normal mensuration formulas? What is the volume of this liquid? If it has a cross-sectional area A, we already know the length and breadth. We'll be given the cross-sectional area. You know, for any prism, the volume is cross-sectional area times height. Do you know that? You must remember this. It's a constant question in physics. Most mensuration questions that they assess in physics, a cuboid, a cube, a cylinder, a triangular prism, whatever, they are all prism. What's a prism, by the way? And we need to talk about that. What's a prism? I think I need to start with that. See, a prism is a solid with a uniform cross-sectional area. Did you see what I wrote? Can you read it out? A prism is a solid or a 3D shape with a uniform cross-sectional area. And this is what I mean. Like a cylinder, which is a prism. If you have a cylinder, let me draw a number of prisms. Can you see what I drew? What do you call this prism? Cylinder. Now, what is the shape of its cross-section? Circle. Uniform means what you have at any point. If you go to the other end, it's the same shape and same size. Once it is the same shape and same size, from one end to the other end, it's a prism. It means it has a uniform cross-sectional area. Is this a prism? Is it a prism?
Yes.
Why is it a prism? Look at the base area. One end is the same thing we have at the top.
Yes.
Did you get that? So you can call this circular prism. Another name for circular prism is what? Please concentrate. This is a circular prism. So a cylinder is a circular prism. What will you call this one? Rectangular prism, because the shape of the cross section is rectangle, isn't it? Now the volume of every prism, by the way, a cuboid is a prism. A cube is a prism. You know, once from one end to the other end, it's the same cross section. Like this end and the other end, you have the same cross section. It's a prism. The volume of every prism is cross-sectional area times height, where the height is the distance between the cross-section. Now what I'm saying is extremely important, because they ask a lot of questions on prism in physics. Okay, volume of a prism. Any prism at all is equal to cross-sectional area times. Okay, let me write it in full. Volume of a prism is equal to cross-sectional area times distance between the cross sections. You can call that height. It doesn't have to be a vertical height. Between two ends, if you like. You can call that height. This is what I'm saying. Are you listening to me? For instance, I can clean this, add more line there. For instance, how do we find it? Assuming the distance from here to here is h. Let me draw that and show you. The distance from here to here is h. It's h. And this, you know, the cross section of How do you find the area of this cross section? Pi r squared. Area of a circle. So what will be the volume of this prism? Remember I said volume is cross-sectional area times the distance between the cross sections. What's the area of the cross section? You told me pi r squared, isn't it? So that will be pi r squared for the circular cross section, isn't it? Times h. Is that not the formula for finding the area of the volume of a cylinder? Did you get that? Any prism, you want to find the volume of any prism, just find the cross-sectional area and multiply it by the distance between the two cross sections. Whether it is a vertical height or a horizontal height. The cross-sectional area multiplied by the distance between the two cross sections. Why I'm saying it doesn't have to be a vertical height is if you have something like this. Let me use this to illustrate. Let me illustrate with this. If I have this, alright, is this a prism? What I just drew here? Because this end is the same as the other end, isn't it?
Yes.
Okay, let me just draw the hidden details so that we can see what I'm trying to say. I can draw it in green so it will appear the same way the other one is. Sorry. So let me shade this cross section, which is the same thing as this cross section. Did you see what I just drew? Okay, so let me ask you, if this place is 5 units, this one is 6 units, and then this here to here is 20 units, what's the area of the cross section I shaded? 30. What's the volume of the area of the cross section I shaded is 5 times 6, which is 30. Okay, what's the volume of this prism? 20 times 30. Because the cross-sectional area is 30. Are you getting what I'm doing? Pardon? 20 times 30, that's 600 units cube. So that's volume. So when I say height, I don't necessarily mean a vertical height. I simply mean the distance between the cross sections. Did you get that? This cross section and the other cross section is what you use as your height. But the general formula for the volume of a prism is what? Read it out. What I wrote in red. Read it out here. Volume of a prism, read it out. Cross-sectional area times distance between two ends, which you can call height. Okay? Okay, let's apply it here to find the volume of this prism. The volume of the water here. Very quickly, let's find the volume of the water here. What's the cross-sectional area? A. And what's the height? H. So that volume is the same thing as AH. Let's write it there. AH. Beautiful. Pay attention, this is important. The volume is cross-sectional area times the H, which is AH. Make mass the center formula. Beautiful, we are making progress. From here, only here. Watch me here, only here. See what I'm circling, please. Look at the screen. Look at the screen, please. Make mass the center formula. Again.
M equals to V times P.
This is rho. Remember where we got this? It's from density equal to mass over volume.
Yes.
Giving us volume equal to mass over density, is it not?
Yes.
So volume is AH. So mass over density is equal to AH. I said make mass inside the formula. So mass will be equal to what? Density times volume, which is AH. AH rho. AH rho. Or A rho H. Is this clear?
Yes.
What does AH itself represent? Volume. Rho, density. So mass is AH rho. So what's the weight? Remember, weight is equal to mg. Please take note of this. We are firing. What's the weight now? Mg. Now we know mass now. So AH rho g. Is it not? Beautiful. So weight is AH rho g. Are you good with that? You know the weight is the force. The weight is what? And you know weight is force. Force. F. So what is pressure again? Force over area, is it not? So substitute it to here to get the pressure now. The weight is the force. Please, I need you to look at the screen. The weight is the force, and we know the force to be this AH rho g, and pressure is force over area. So let's substitute. So pressure will now be equal to AH rho g for the weight, is it not? Divided by A. So it will be AH rho g divided by A. And so what will happen? A crosses out A. H rho g is pressure in fluid. Therefore, pressure in fluid is equal to H rho g, or if you like, rho gh, whichever way you want to write it. That's the popular formula you know, rho gh. That's the pressure in fluid, rho gh. Okay? The height is simply the depth of the fluid. So what does that tell you? When you go deeper, by the way, the depth of the fluid from the top, as you are going deeper, what do you think will happen to the pressure? It will increase, because it depends on the height, which is the depth. It depends on the density of the fluid, and of course G. G is a constant. So it means this pressure in fluid. All right, let me now write the general formula. Anyway, you told me that this one is the volume of this one would have been. Let me just write it down so that we don't forget. Volume of this one will be cross-sectional area times height, if you like, or length, which would have been 5 times 6 for this cross-section. Let me just write it there. 5 times 6 for this cross-section, then times the length, which is 20 times 20. Okay, and that would have been, because it's also a prism, and that would have been 600, you said 600 units cube, whatever the unit is, a super 3. Okay, I'm going to rule a line so that we can continue our analysis. So we have discovered that pressure in fluid is rho gh. So it depends on what factors? It depends on density. And no, gravity is a constant now. Gravitational field strength is G, and then the depth. The deeper you go in a fluid, the higher the density. If you have two fluids, one with a bigger density, sorry, what did I say? The deeper you go in a fluid, the higher the pressure. Is that what I said earlier? All right. Also, if you have two fluids, the one with a bigger density will also have a bigger pressure, because pressure in fluid depends on density and depth. All right. I just need to point out this. Look at this fluid. Just to take you through what we have done, we have covered this, define density and use density. We've covered this, use pressure, we've covered this. You can easily use this. That shouldn't be a problem, isn't it? And just use change in pressure is PGH or rho GH. You can apply that. You've done that at O level. So I just want to point out this. Understand that the upthrust acting on an object in a fluid is due to a difference in hydrostatic pressure. I want to explain it here. Watch this. This is an object that is partially immersed in water or in the fluid. The fluid is this blue one I colored. It's partially immersed. Are you listening? Now, you know the weight of this object acts from its geometrical center, the center of gravity. It acts downwards. I think I should. Let me use a different color to represent the weight. The weight acts downward, is it not? Are you ready? Good. Between point A and point B, between point A and point B, there's a difference in pressure. Ignoring pressure in air, atmospheric pressure. Are you listening to me? We can say the pressure at point A is 0. I mean, just ignoring atmospheric pressure. Then the pressure at point B is rho GH. Are you listening to me? So there's a difference in pressure between here and here. That's what I'm saying, between point A and point B. Also, if I had point C here, you know there's a difference in pressure between point C and point B, because the pressure at C is rho GH. That's the depth at C. The depth at C and the depth at B, are they the same? Which one will have a bigger pressure? B will have a bigger pressure. So between point B and point C, there's a difference in pressure, is it not? Just like between point B and point A, there's a difference in pressure. That difference in pressure, what I will call pressure difference, delta P, we produce a force that will push this thing up. And you know that pressure is equal to force times area, isn't it? Pressure is what? Oh, sorry. Pressure is force over area. I was trying to talk about. Thank you for. I would have continued with that wrong analysis. Pressure is force over area. So what is force?
Force is mass.
Let me give this one different letters so that it doesn't look like the A for the area I wrote here. The D is here and the B is here. So what if pressure is force over area? What is force?
Force is pressure times area.
Yeah, yes. Force is weight, but use the formula here.
Force is pressure times area,
isn't it? So F is change in pressure times area. Are we good on that?
Yes.
Change in pressure times area. Change in pressure times area. Okay, that's the force. Now, watch this. That force will produce an opposing force that will be pushing upwards, what we call upthrust. So I'm going to represent that with a red line, upthrust. You know, that's the force that will cause this thing to float, because the weight acts downward, the upthrust acts upward. Upthrust is the force that acts in any object that is inside a fluid. I need to define that. Let me just write it down. Upthrust. U is the force in the opposite direction to the weight, or you can say the upward force. To weight that acts on an object which is whether partially or totally immersed in a fluid. Partially means, like, is this one completely immersed in this fluid? This object I drew in red, is it completely immersed? No, it's partially immersed. Whether it is partially or totally, anytime an object is inside a fluid, an upthrust acts on it. A fluid, what's a fluid? Liquid or gas. It's a fluid. So upthrust. So while you are inside air, upthrust acts on you. If you are in water, upthrust acts on you. The value of the upthrust is what we're finding now. Upthrust U is the force in the opposite direction to weight, which acts you know, act on an object that is immersed partially or completely immersed in a fluid. So the weight acts vertically downwards. That's the weight, the one I represent in yellow. The upthrust acts upward. The weight acts downward. The upthrust acts upward. It is the pressure, the difference in pressure that produces that upthrust. This difference in pressure is force over area, is it not? And the force is the difference in pressure times area, isn't it? So let's find that up. Remember that upthrust is the force. The upthrust is the force, U. So what would be the, okay, let's, what did we say is the formula for pressure again? What we got it to be this now. What did you say is the formula for pressure? Rho GH, isn't it? Okay, so that difference in pressure is rho GH. Let me zoom in again to 100. So that difference in pressure is rho GH. Are you ready? Rho GH, isn't it? That's the pressure, then times the area. So rho GHA. Are you listening? Did you get that? Did you get that? Okay, I said pressure is force over area, and force is change in pressure times area. And we already know the formula for pressure. What's the formula for pressure again? Rho GH. So that force is rho GH times A. What is HA? Again? Please, what's HA? A is cross-sectional area times height. Oh, sorry, A is cross-sectional area. Height is, H is height. A is cross-sectional area, H is height. So what is HA? Volume. So what can we say would be the value, the formula for F? Rho GV. You see that? So F is rho GV. Rho GV. You can use any of these things to find the upthrust. Remember I said that force is the upthrust. So the force which is equal to the upthrust is equal to rho GV. All right. I just needed you to take note of it. So you see where we are. Read this again. Read the last. I've said, understand that the upthrust acting on an object in a fluid is due to the difference in the hydrostatic pressure. That upthrust is because of the difference in hydrostatic pressure. That's what I explained here. Are you ready for the summary now? There's a difference in pressure at D compared to B. Isn't it? Because they are at different depths. Ignoring air pressure, we can say the pressure at D is 0. The pressure at B might have a value. So the difference in pressure is between here and here. And that difference in pressure is force over area. The force is pressure times area. That force acts upward to oppose weight. And that's what we call upthrust. The force in the opposite direction to weight, which acts on an object that is partially or completely immersed in a fluid. Once the upthrust is equal to the weight, what happens? If the upthrust is equal to the weight, it's in equilibrium, so the object will float, is it not? Yes. So flotation is when upthrust is equal to weight. If weight is bigger than upthrust, what happens? It will sink. If upthrust is bigger than weight, it will rise. That's why sometimes you try to push a plastic into water. If you dip it, force it to go down, to a point that up thrust is bigger than weight, and you release your hand, what happens? It springs back because up thrust is bigger than weight. Now you are dropping a piece of stone into water. Even though whether it is partially immersed or completely immersed, the weight is always bigger than the up thrust. So it will all eventually sink. Now I need you to understand that up thrust, this is very, very important. What are the factors that determine the value of the up thrust? See the formula for up thrust now, which is the force. What are the factors, the quantities that determine the value of the up thrust? Density and volume, because G is a constant. So the bigger the density of a fluid, the bigger the up thrust you will experience. The bigger the volume of the water displaced, the bigger the up thrust. This is what I'm saying. Are you listening to me? The more volume. For instance, see, this is the point. Listen to me. Listen to me. The volume of water displaces as a result of from here to here. Just imagine before we dipped this thing down. This is a solid. We partially immersed in water. You know, before we immersed it in water, the water level would have been somewhere here. Initial level of water, isn't it? Okay, let me use something realistic. Let me say the initial level of water would have been here. Okay, I can even graduate it. I can graduate it 10, 20, 30, 40, 50, 60, 70, 80, and 90. Maybe in centimeter cube or whatever unit. Now this was the initial volume before I immersed this fluid. Initial volume. Initial. That is before we dipped this thing inside. Now, you know, once you dip this thing inside, the water level will rise, isn't it? Do you agree with me? The water level will rise. So this now is the final volume. It rose to 90, final. What's the volume of the water displaced? It was at 60 and it has risen to 90. What's the volume of the water displaced? 30, because 90 minus 60 is 30. That's going to determine the value of the up thrust, because up thrust is affected by volume. So what it means is if I dip this thing further down such that the water rises higher, it means it's displacing more volume, isn't it? Which means a bigger up thrust. The deeper you dip that stuff, if it's going to displace more water, there will be bigger up thrust. In fact, Archimedes stated that, what we call Archimedes principle. Archimedes principle is the up thrust experienced in a fluid experienced in an object which is partially or fully immersed in a fluid is equal to the weight of the water displaced. Weight of the fluid displaced. Please read this. The up thrust experienced in an object which is let me say that again. Archimedes principle. The up thrust experienced in an object which is partially or fully immersed in a fluid is equal to the weight of the fluid displaced. This is what I'm saying. Listen to me. Are you ready? Are you ready for that? Okay. What was the initial volume of this thing before we immersed this object? 60 centimeter cube. What's the final volume? 90. What's the volume of water displaced? 30. Now, for this example I have above, let me just do a simple analysis. Initial volume of water, now that's before immersion, before immersing before the solid was immersed, right? So I could just say before immersion, 60 cm cube. Are you ready for that? Final volume after. (90 cm cube). Did you see that? So I said the upthrust experienced in an object which is partially or fully immersed in the fluid is equal to the weight of the fluid displaced. So what is the volume of the fluid this water displaced, first of all, before we even find the weight? The volume is volume of water displaced. I'm using this example above. Are you ready? What's the volume of this water displaced? 90 minus 60, which is 30 cm cube, isn't it? That's the volume V. How do we find the weight? How do you find the weight? You find the mass, first of all. From the mass, you can find the weight. What's mass? Remember, mass is density over. Are you ready for that? Okay, you know the density of water. Do you know the density of water? Yes. Density of water at about 4 degrees Celsius is 1 grams per cm cube, or 1,000 kilograms per meter cube. Did you see that? I said the density of water is what? 1 gram per cm cube, or 1,000 kilograms per meter cube. That's the density. Since we know the volume, why I decided to write it in gram per cm cube is because the volume I have here is in cm cube. Did you get that? So we know the density. Can't we find the mass? What's the mass? Are you sure? Mass is equal to density is mass over volume. Where did we write it? So mass is equal to what? Density times volume. Density times volume. Rho V. Because density is mass over volume. So mass will be density times volume. So the density of water is 1 gram per cm cube. The mass, the volume is 30 cm cube. I'm talking about the density of the water displaced. I said 1,000 kilogram if it was in kilogram per meter cube. Why did I use the 1 gram per cm cube? Because the volume of the water is in cm cube. The volume is not in meter cube, so I decided to use the other units. Are you still following? Okay, so what's the mass now? Let's do this simple arrangement. 30 times 1, is it not? Or 1 times 30 if you like. 1 times 30. Which is 30 grams. Watch what I'm doing. Please listen up. The 1 is the density, which is 1 gram per cm cube. The volume is the 30 we got. So 30 grams. So what's the weight of the water? Let's do that. Weight of the water. Let's go. Weight of water. Mg now, is it not? Mass times G. And you need to be very careful. This 30 is in grams. So you need to change to kilograms. Anytime you have, please take note of what I said. Exactly. This mass is in grams. You need to change it to kilograms if you are finding weight. Before you multiply by G, you have to change the mass to kilograms. So that will be 0.03 in kilograms, is it not? Yes. Then times the G. If you like, let's use 9.81. What does it give us? Please just get the value quickly. 0.03. By the way, 0.03 is 30 divided by 1,000. That gives us 0.03 kilograms times 9.81, which is G. What does that give us? Quickly. That would be around 28, 29. Oh no, maybe 2 7. 0.03 times 9 point.
0.294 kg.
Again?
0.294 kg.
0.294 Newton now. 294 Newton. So I said all of this to say this. This weight of the water displaced will be the upthrust that this object will experience. Watch me. I'm summarizing. Read this statement again. The one in yellow, Archemedes principle. Read it again quickly, very quickly. The upthrust experienced in an object which is partially or fully immersed in a fluid is equal to the weight of the fluid displaced. Now we found the volume of the fluid to be 30. From the volume of the fluid, we know the density and we find the mass. From the mass, we found the weight. And the weight is 0.294 Newton. That will be the upthrust this thing will experience. That will be what? Are you listening to me? That will be the value of the upthrust. So the upthrust this thing will experience will be 0.294 Newton. 0.294 Newton based on our calculation. Okay? Alright. See where we all started from. And yeah. Now these are some practice questions on the pressure, hydrostatic pressure that we've done. It says a cylinder is suspended from the end of a string. The cylinder is stationary. Are you listening? The cylinder is stationary in water with the axis of the cylinder vertical as shown. That's the cylinder, as you can see. And the weight of the cylinder is what? 0.84 Newton. The density of the water is 1.0 times 10 per 3 kilogram per meter cubed. And the diameter of the cylinder is 0.031 meter. Now it's all of this information inside. This data is given. And it says the difference between the pressure at the top and bottom of the cylinder. The pressure here, watch me, the difference between the pressure here and the pressure here. The top is of the cylinder is here, the bottom of the cylinder is here. The difference between the pressure is what? 520 pascal. Calculate the height of the cylinder. This one is a walkover now, don't you think so? What is the big deal in that question? That's a serious walkover. We are giving the difference in pressure to be 520 pascal, which is 520 Newton per meter square. What's the formula for finding pressure in liquid or fluid? Go ahead, I'm listening. Good. Change in pressure in liquid is rho GH. Rho GH. What does rho stand for? Density, G, gravitational field strength, H, depth. And that's what you're asked to find. What's the value of that change in pressure we're given? So you just simplify, isn't it? Please, I need you to use your calculator quickly. So 520 is equal to, what's the density of the water? 1.0, that's 1000, times G, 9.81, times H. So just find H quickly. So height is what? Very quickly. You don't have a calculator. Use your calculator, please, now, so that we don't waste time.
That is giving me my,
Did you get what I just did? Let's be fast about it.
I don't know. That's 520.
Go ahead and do that very quickly. 9,810 or something if you like.
That's 0.05.
That's possible. Who said it's wrong?
0.05.
0.05 what? 053. See, how many significant figures should I stop at? Hello? How many significant figures do you have here? This one, 2. The least is what? The answer should have how many? 2. 0.053 meters. Is that understood?
Yes.
What's the next question?
Next question.
Show that the upthrust acting on the cylinder is 0.39. It's all of these things are done for you. There are many ways you can do that. I've told you that the upthrust, which is the force, that's the upthrust, is rho GV. Do you remember? You want me to remind you of that? Where did we write the formula? The previous page. This is upthrust, rho GV. Is it not? We proved those things earlier. This one is a walkover. All of them walkover questions that you are giving here. It shouldn't have given you any difficulty. So rho GV, quickly. And what should I give? The density of the water is given 1000 times G, 9.81. All you need to do is to find the volume of the fluid displaced. And the volume of this cylinder, because it's completely immersed, it is what? The whole cylinder will displace an amount of liquid equal to its volume. Remember I told you that upthrust, if you need to read it again, Archemedes principle. Let's read it out again. The upthrust experienced in an object which is partially or fully immersed in a fluid is equal to the weight of the fluid displaced. The upthrust is the weight of the fluid displaced. So you can find the weight of the fluid displaced to get the upthrust. And we proved all that. That's how we're able to get this rho GV. If you like, you can find the volume of the fluid and all of that. But the weight of the fluid displaced is the upthrust, which is rho GV. So rho GV, that means you need to find the volume of this cylinder, okay? That shouldn't be a big deal, should it? You already know the height. You found the height, and you found, what is this? What's the cross-sectional area? What's the cross-sectional area? What's the shape of the cross-section? Circular. And what this thing that is a circular cross-section, that's the diameter. So you need to find the radius, isn't it? By the way, if this wasn't given in meter, you must convert it to meter. I hope you know what I'm talking about. Because you should always work in SI unit. If it was given in millimeters, you should convert to meter. Do not fall for that trap. If it is given in minute, convert to second. If it's given in kilometer, convert to meter. In any other unit in length, convert to meter. Any other unit in time, convert to seconds. Any other unit in mass, convert to kilograms. Is that understood? Okay, so this is the diameter 0.031. So what's the radius? Diameter is 0.031 meters. So radius is what? 0.031 divided by 2, isn't it? You know how to find radius from diameter, am I right? So what does that give you? 0. No. Leave it to at least 3 since it's not the final answer. Now, when it is not the final answer, leave it to a higher significant figure. Did you get what I'm saying? It is at the final answer that you now have to make sure it is the same significant figure as the least significant figure of the values given. But anything before the final answer should have a higher significant figure, a higher number of significant figures. So 0.015 what? 5 meter is the radius. And you know cross-sectional area is pi r squared, isn't it? That will give us 0.0155 squared pi. Quickly, I think we should let's just go straight to find the volume. Volume of a cylinder is what? Pi r squared h, isn't it? Yes. Because it's a cylinder. Yes, the shape is a cylinder. That's what you're trying to find. Why am I doing that? Because the formula says what? Rho GV. I already have rho. All I need is to get my V. So pi r squared h, which is 0.155 squared pi, then times the h. What did we get for our h? 0.053. We got the h to be 0.053. So times 0.053. Quickly, please impute this in the calculator. Get the answer so that I can work very quickly, very quickly. That's pi times 0.155 squared times h.
So that's 0.00040.
0.000. That's how many zeros?
There's 4 zeros before the 4.
4 what?
0.
Another 4 0, right?
Yeah.
4 0. 4 0 what?
That's it.
Just 4 0.
Yeah, after the 4 0, there's not like 2 more zeros before 90.
Okay, 4 0 is fine. So now you can find the force, which is the up thrust. What's the formula again? Rho GH 1000 times 9.81 times 0.0155. No, times what? Times 0.0004. 40. I hope what you gave me is correct. Oh.
Yes.
Alright, let's go. Give me.
0.390.
Is it 0.390? 0.39. Is that not what is given?
Yes.
Have you proven it?
Yes.
Good, because you say you should show that the up thrust is 0.39. Is that proven? Isn't it easy enough? 0.39 Newton. What else are you asked to find? Listen, calculate the tension in the string. Now you listen very attentively. This one is even easy. Calculate what? Good, and a very good question. It's actually easy. Everything I've done here is the same way you will do all the other ones I'm going to ask you to complete or practice. Watch this. Are you ready for that? What's the weight of the cylinder? What's the weight of the cylinder? Please look at the screen now. I'm circling it. What's the weight of the cylinder? Please look at the screen. 0.84 Newton, isn't it? How does weight act? Vertically downward, isn't it? If this is the center of mass or center of gravity, the weight acts vertically downward like this. That's the weight, which is 0.84 Newton. How does the up thrust act? Vertically upward. So let's represent the up thrust that we just found now. Let me use the yellow line to represent the up thrust. It acts vertically upward like this. Up thrust. What value did we just get for the up thrust? 0.39 Newton. Will this thing be balanced by these two forces alone? This is 0.39. This is 0.84. Are they balanced? So what does that tell you? But this thing is in equilibrium.
Yes.
This stuff we are told is stationary. Look at it. Read it. The cylinder is what? Read it out now. Stationary in water meaning that it is balanced. But these two forces are not balanced yet. So what does that tell you? Talk to me. There must be another force acting in what direction? Beautiful. There must be another force acting upwards. Are you getting this? What's the value of that second force acting upward? Let's represent the second force, which we are looking for now. That's the tension of the string, the T that the string is provided to keep it balanced. So for equilibrium, up thrust plus tension must be equal to the weight, is it not? For vertical equilibrium. So let me write it. For vertical equilibrium, let me write it in yellow. Or for equilibrium of vertical forces. For equilibrium of vertical forces, what are the forces that act vertically? up thrust, the tension we are looking for must be equal to the weight, is it not? Up thrust plus the tension must be equal to the weight. So, for equilibrium of vertical forces, the up thrust plus the tension must be equal to the weight. And the tension is what we're looking for. It says calculate the tension in the string. So, we already found the up thrust to be what? 0.39, isn't it? And we know the weight. The weight is 0.84. So we can find the tension. So up thrust, which is 0.39, plus the tension we're looking for is equal to the weight, 0.8 what again? The weight is what again? 0.84. 0.84. So the tension is what now? 0.84 minus 0.39. Do you understand? And what does that give you? Quickly. 0.84 minus 0.39. 0.45 Newton. Okay? This is easy enough. And all these other ones, I hope you can do. Look at this one. Let me zoom it out so that you see it better. Look at this. See the question. It says, black with all the stories. And it says, show that the pressure P due to the liquid on the base of the cylinder is given by P equal to rho GH. What are they asking you to do? Prove all those things I proved for you earlier. That's why you need to understand the proof. See, remember when we carried out the proof, all of it here. So you need to understand the proof because it's a recurring question. This is all they want you to do, to show that P equal to rho GH. And the second question is saying what? Every other thing given, you'll be able to do that. Then it says pressure is plotted against height. That says the variation of the height h, the total pressure is shown. Explain why the line does not pass through the origin. 0, 0. Why doesn't pass through the origin? You need to look at that and think about it. And then it says use the data from figure 2.2 to calculate the density of the liquid. It's not as difficult as you may think. Just look at it carefully. Use from this to calculate the density of the liquid. Pressure, listen to me, see, pressure and height. What's the formula for pressure in liquid? No, because there's no area here. What's the formula for pressure? Rho GH. The pressure is given, the height is given. You just look for a particular pressure. Are you listening to me? Look for a particular pressure and trace it to its height. So at least we know a particular value of pressure, a particular value of height. You know G. So you use that to find rho. Because pressure is equal to rho GH. You understand? Are you getting what I'm saying? And then the other question, you can also attempt it. It says, a cylinder is suspended, blah, blah, blah. This is the same one we did. Did I copy it twice? Okay, I mistakenly copied it twice. Alright, there could be other ones you can attempt, you know. There are many other ones you can attempt. Let me see this one. The other ones you can attempt here. Let me see. Let me see this. Well, these are some of the questions. I'm just looking for anyone that, even this one that has something to do with both pressure and moment. Look at it. It says the cylinder is immersed, blah 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 blah. An up thrust of the cylinder is on the bar is in equilibrium. Explain the origin of the up thrust. I told you why up thrust acts. Up thrust is equal to the weight of the fluid displaced. So and it acts upward. Explain why the weight of X must be reduced in order to obtain equilibrium. We're going to be talking about principle of moment. Apply moment to discuss that better. Then I think this is the one we did earlier. There should be another question. Let me see. I will put this on the Jamboard. Okay, look at this other one. Show that the mass, it shows the metal cylinder of height, this density of the liquid is this, or the density of the metal is this, show that the mass of this, of course you could just use density mass over volume, isn't it? And then it says, the cylinder is placed in a blank as shown. You need to resolve forces. Do you see, can you see this? You know how to resolve forces. Draw down the weight and the normal reaction. Do you see what I'm talking about? We need to get the weight acts vertically downward, the normal reaction, and then you'll be able to, this is something like this. Let me show you. It's something similar to this. Similar to this. Watch me. The cylinder is placed this way. You draw the weight, this yellow line, and you find the component of the weight, the component perpendicular to the plane and the component parallel to the plane. Then you also get the normal reaction, this green line, and you'll be able to get whatever you're looking for. Remember the frictional force. Are you listening to me? The frictional force must be equal to this one now, is it not? The frictional force must be the component of the weight parallel to the plane that is acting downward. That's for equilibrium of forces. This F must be equal to this, is it not? And then the normal reaction must be equal to this, is it not? So normal reaction is equal to W cos 20. In this case, the frictional force must be equal to W sin 20. Because this is the weight shown in yellow, and these are the components. So there's nothing in this. Whichever way it comes, you should be able to trash it. You know. I hope that's fine. Whether it is this question, you can also apply it. The cylinder is in equilibrium when in mass. Explain it in terms of forces acting on the cylinder, why it's in equilibrium. For it to be in equilibrium, are you listening to me in this particular question? For it to be in equilibrium, total upward forces must be equal to what? What is the only downward force on this cylinder? Weight. Good. What are the upward forces? The upthrust and the tension. So upthrust plus tension must be equal to weight. Now it says calculate the density of the oil. You'll be able to do that using the information given. These are the values given. You'll be able to get that. You know, define density and all of, calculate the diameter. You know, use these to determine the value of D and absolute uncertainty. This one requiring understanding of uncertainty. Okay? You know, I think that should be fine.